So for data set 2, we're going to be exploring volume. In chapter 1, we learned about volume, and volume is basically measuring the amount of space that's occupied by a substance. And so in the laboratory, we use a piece of glassware that I have here in my hand called a graduated cylinder. So the graduated cylinder is able of measuring the volume of a liquid. And so what you're going to do now is you're going to examine this graduated cylinder. And so graduated cylinders are usually divided up into milliliters, which has the symbol lowercase m, capital L. And so we talked about this unit of measurement in chapter 1 as being one of the more popular units for volume. And so while examining this graduated cylinder, go to your second set of inquiry questions, and you will answer those questions based on your visual inspection of this graduated cylinder, and also based on the picture that you see within those sets, within that data set 2 set of questions under letter number L. So again, go to your data set questions, set 2, answer questions letter number H, all the way through letter P. So in question H, it asks you, what would you use to measure in this graduated cylinder? Would you use it to measure liquids? Or would you use it to measure solids? Or would you use it to measure both? And give me a reason for your answer. Why would you use it to measure liquids only? Or why would you use it to measure solids only? Or why would you use it to measure both? Question I requires us to look at the markings on our graduated cylinder. How many milliliters can we accurately measure in this graduated cylinder? So take a look at the markings and answer that question. Question J, what value does each of the markings or each of the lines that are on this graduated cylinder represent? So what value does each of the marks or lines on the graduated cylinder represent? And then what if we put some liquid in the graduated cylinder? And what if the level of the liquid was between 2 of the markings? How would we record the volume if it's right in the middle between 2 markings? How would you record the volume? Question L, you're going to use the picture that is provided for you on the data sheet for question L. So when we place liquids in our graduated cylinder, we usually observe what's called a meniscus. The meniscus is a curvature that we see at the surface of that liquid. So we will almost always see the meniscus as indicated in this picture here. And so this graduated cylinder that we're using is pretty large in nature, but then there are also much smaller graduated cylinders that may have a 25 mil capacity or a 10 milliliter capacity. So the smaller the diameter of the graduated cylinder, the more markedly visible the meniscus or the curvature is. And so by our graduated cylinder here being pretty large, you're not going to see that meniscus curve as directly as you would if we were using a 10 milliliter graduated cylinder, for example. And so if we take a look at the picture here for question L, what would be the recorded value for the volume of the liquid in this graduated cylinder here in this picture? Make sure you examine it carefully. Check the answers with your group members. Make sure you all agree on what the volume is represented in this picture. And always read the bottom of the meniscus or the curve. And notice how the graduated cylinder picture here is divided into these lines or markings. So this dark line here would be the 25 milliliter mark, because it's right in the middle between the 20 and the 30. So we know that we have less than 25 milliliters because the bottom of this curve is below the 25 mil line. So with that in mind, get a good estimate of the volume of the liquid in the picture of the graduated cylinder. Next, question M. If you want to measure the volume of the pennies, could you do it by just putting the pennies in the graduated cylinder and then reading the volume? Could you do it that way? Yes or no? And then explain why you can or why not. If you can't, then why not? So you want to ask yourself, is a penny a solid? Is it a liquid? Or is it a gas? If a penny is a solid, then it has its own shape and its own volume. And it's not going to take on the volume of the graduated cylinder. So therefore, that should give you some deeper insight on how to answer that question. Question N, if we fill the graduated cylinder to the very, very top so that it's almost overflowing with water, and then we start to add some pennies. Let's say if I added 5 pennies, how much water would spill out of the cylinder? Then the last question, P, a good way to determine the volume of solid objects is going to be through a method called the volume displacement method. Because solids have their own shape and volume, you can't use the direct graduated cylinder measuring method. You have to use what's called the water displacement method. The water displacement method measures the volume of water displaced by an object. In our case, it's going to be what volume of water gets displaced by the pennies. And so therefore, the amount of water that gets displaced is going to be equal to the volume of the object. And so that's going to be the way in which we're going to determine the volume of a penny is by the water displacement method. And we'll continue on with that procedure for data set 3.